Hi, fourth grade. Today we're going to be looking at equivalent fractions. So when you hear the word equivalent, what word do you hear? Well, I hear the word equal. So you're absolutely right. In the word equivalent, you hear the word equal, and so we're going to be talking about fractions that are equal to one another. Equivalent fractions name the same part of a region or set, or the same part of a whole. So if we looked at this example, this is one whole. Well, if I took that whole and I broke it into two parts, I would now have halves. I would have two halves. If I shade one part of this whole, I'm shading one half. So one half is represented. Well, if I decide to shade the other half, if I decide to shade the other half, then I have now shaded two out of two parts. So this fraction would be represented as two halves. Well, we see that the exact same amount of space has been shaded. So that lets us know that two halves is equal to one whole. Well, say we then split this whole into four equal parts. Now we have fourths. Well, I've shaded all four of the fourths. So that fraction would be represented as 4/4. Well, we can also see that 4/4 is the same shaded area as two halves or as one whole. So all of these fractions that are listed are equivalent fractions. One whole is equal to two halves, which is equal to 4/4, 8/8, 100 100ths, 20 20ths. So anytime all of the parts of the total parts are shaded, then that's going to be equal to one whole. So that's something that you want to remember. So here's another great example of equivalent fractions. Here we have one whole circle. Okay, this is equal to 1. But we could break this up, and you'll see that we actually have two halves. So those two halves are equal to one whole. Well, if I decided to split my circle into fourths, so for example, I drew a line right here, my whole is now broken up into four equal parts, 1, 2, 3, 4. Well, we know that this is one half of the circle. So covering one half of the circle is 1/4, 2/4. So those are equal fractions, equivalent fractions. So we now know that 1/2 is equal to 2/4 because the same amount of space is covered. Okay, well now I'm going to break this circle up into eighths. Sorry, that's not a very straight line. But if we took the whole and put these lines here, we now have this whole is broken into 1, 2, 3, 4, 5, 6, 7, 8 equal parts. So we know that this is eighths. Okay? Well, I can see that 4 of these eighths is equal to 1/2. I can also see that 2 eighths, when put together, is equal to 1/4 or 1/4. So here I'm looking at a visual that is showing me what equivalent fractions look like. Another tool to use to look at equivalent fractions is to use an equivalent fraction table. And you have a table just like this in your textbook. So looking at this table, here this red bar represents one whole. Well, we see that two halves take up the exact same amount of space, the same amount of parts as one whole. Okay? We see that 3/3 takes up the same space as one whole. 4/4. Okay? So not only can we see how many of each part equals a whole, but we can also compare other parts. So if I laid these fourths on top of the half, I can see that only 2/4 goes into 1/2. Or I could see 1, 2, 3/6 right here could fit onto that 1/2. So here I'm showing you that if you literally lifted these 3/6 up and laid them on top of the half, we could see that these 3/6 would fit perfectly into 1/2. So that means that 1/2 is equal to 3/6. So now I've decided to cut my half all the way down. So we'll see that some fractions don't go evenly into a half, but if we look down, we see that 1, 2, 3, 4/8 fits exactly into 1/2. 5/10 would fit exactly into 1/2, and 6/12. So using the fraction table is a great way of looking for equivalent fractions as well. If you look over here, we have 3/4. You'll notice that 6/8 takes up the same amount of space. So they are equivalent. They name the same amount. They name the same fraction. So using the fraction table is a great tool, but you don't always have to use that in order to find equivalent fractions. In fact, I think an easier way is to use multiplication. So to find equivalent fractions, we have to multiply the numerator and the denominator by the same number. So let's refresh and remind ourselves that the numerator is the number on top, and the denominator is the number on the bottom. Okay? So in this problem, we're trying to figure out what the equivalent fraction to 3/4 is. Well, in this fraction, they've already given us the denominator of 8. So we need to figure out which fraction would be equal to 3/4. What you have to ask yourself is, how can we get from 4 to 8? Well, most of you know that if you multiply 4 by 2, you get 8. And so the rule is, whatever you do to the bottom, you have to do the top. Or whatever you do to the top, you have to do to the bottom. So we multiplied 4 times 2 to get 8. So we also have to multiply the top by the same number, by 2. So we multiply 3 times 2, and we get 6. So that tells us that 3/4 is equal to 6/8. So here's a visual to share that same information. So this whole has been broken up into fourths, and 3 of the fourths has been shaded. So this is a fraction of 3/4. Well, this whole has been broken up into eighths. 1, 2, 3, 4, 5, 6, 7, 8. And we have shaded 6 of the eighths. And so if you compare these two, we see that the same amount has been shaded. So that tells us that these fractions are equal, that indeed 3/4 is equal to 6/8. So here's another example. We're looking at 1/3, and we want to find the equivalent fraction in ninths. So if you look at our image right here, I can quickly visualize this is 1/3. So how many ninths covers that same amount of area? Okay, what is equal to that? But you have to be able to do it not just visually, but mathematically as well. So remembering our rule, whatever you do to the top, you have to do to the bottom. Or whatever you do to the bottom, you have to do to the top. So we need to think about, how can I get from 3 to 9? Okay, think multiplication. Well, we all know our fast facts, and we know that 3 times 3 equals 9. So we're going to write that down. 3 times 3 equals 9. Now we go back to our rule. Whatever we do to the bottom, we have to do to the top. So we're also going to multiply our numerator by 3. So we've already multiplied our denominator, now we're multiplying our numerator. 1 times 3 is 3. So mathematically, we know that 1/3 is equal to 3/9. Well, if I go ahead and shade 3/9, I can easily see that obviously these two fractions are equivalent. They are equal. They cover the same amount of space. Here's another example, and we're going to do it without looking at a visual. So we need to remember the rule. Whatever you do to the top, you do to the bottom. So here we have 3/5, and we want to find the equivalent fraction. And all we know is that the numerator is 12. So again, we need to think. 3 times what equals 12? What do we have to do to our numerator to get to 12? And so knowing our fast facts, you should quickly think, okay, 3 times 4 is 12. So I'm multiplying that numerator by 4 right here. And then we remember our rule. Whatever you do to the top, you have to do to the bottom. Since we multiplied the numerator by 4, we also have to multiply the denominator by 4. So 5 times 4 equals 20. That tells us that 3/5 is equal to 12/20. They are equivalent fractions. So when you think of equivalent fractions, listen to that word, and I want you to hear equal. And the strategies that you can use are, you can draw a picture, you can use the table in your textbook, or you can go ahead and multiply.